all numbers can be written as something called a product of prime factors. Product of prime factors you may hear being called factor trees, or you just may be asked in an exam to write the product of prime factors. If we have, for example, the number 42, what we do is what I call a factor tree. I know that the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and they'll keep going. So what I do when I do a factor tree is look at these numbers and see which one I can divide this by. I can divide it by 2, and then I circle that one. That is prime. That now leaves me with 21. And I say to myself, can I divide that by 2? And I can't. But I can divide it by the next prime number, which is 3, which gives me 7. And 7 is prime. So 42, as a product of its prime factors, can be written as 2 times 3 times 7. Because we can't break those down any further. As soon as you're hitting the prime numbers, it's done. So let's look at another one. 36. That can be divided by 2, and that gives me 18. 18 can be divided by 2, which gives me 9. 9 is still not a prime number, so I need to divide that. I can't divide it by 2, so I divide it by 3. 3 is prime, and that leaves me with 3. This can be now written as 2 times 2 times 3 times 3, or 2 squared multiplied by 3 squared. So 2 to the power of 2 multiplied by 3 to the power of 2. So this is all you're doing. You're basically working them out from here. Let's have a look at 54. 54 can be divided by 2, which now gives me 27. Now at this point, hopefully you can start spotting some patterns. 27 is 3 cubed, and we'll show that. It can be divided by 3, which gives us 9, and it can be divided by 3, which gives us 3. So 54 as a product of its prime factors is 2 multiplied by 3 cubed. Now, what use can we make of these? This is prime factorisation, product of prime factors, decomposition of prime factors, factor trees. You'll hear it called a lot of things. We can use it for things like the highest common factor and the lowest common multiple. So let's look how we can use it for those. I know that 36, so if we said what's the highest common factor of 36 and 54, the biggest number that goes into both, we can look at this list. 36 as a product of its prime factors are 2 multiplied by 2 multiplied by 3 multiplied by 3. 54 is 2 times by 3 times by 3 times by 3. To find the highest common factor, I've done a video on highest common factor. There are plenty of ways of doing this. What we do is look for factors that are common in both lists. 2 is common in both lists. One set of 3's is common in both lists. And another set of 3's is common in both lists. So we can say that the highest common factor is 2 times 3 times 3. So 2 times 3 times 3. And that's going to give us 18. So the biggest number that goes into both of these is 18. And if we think about it, 18, 36, 54. Now if we look at the here, you're going to see that they're both in the 18 times table. So 18, 36 and 54, there we go, they're both in there. So that's one way of looking at highest common factor. Certainly not the only way. Lowest common multiple. Now, there are a couple of ways we can do this using this information. The first way is to look at the two lists again. So 36 was written as 2 squared multiplied by 3 squared. 54 was written as 2 times 3 cubed. What we need to do to find the lowest common multiple is take every number in each list. In this number, we've got a 2, So in my list we've got a 2 and a 3. And we've got to look at what highest power they've got in both lists in total. The 2, I've got a choice of 1 or 2, so I have to use the highest one, which is 2. In this one I've got a choice of squared or cubed, so it's cubed. This will now give us the lowest common multiple. 2 squared is 4, 3 cubed is 27, so the lowest common multiple is 108. The lowest common multiple is the first number they both go into. Now let's have a think about this. 54, the 54 times table goes 54, 108, and then it's going to go 162. Let's just do that, 162. The 36 times table goes 36, 72, 108. That's the first number they both go into, and we can use that information. Another way you could find the lowest common multiple is multiply the two numbers 36 times by 54 and divide it by the highest common factor. So now that we've got that information, 36 times 54 over 18, you might look at that and think, well, that's a bit of a hassle, but remember we can cancel off. The 36 and the 18 will cancel to 2 and 1, as there are 2 18s in 36. So all we've got now is 2 times 54 over 1. 2 times 54 is 108 over 1, which is 108. So there's some factor trees. Prime factorisation, you may hear it written, or in an exam it will say write 42 as a product of its prime factors, which is 2 times 3 times 7.